Deadlock is one of the most important topics in operating systems. It occurs when two or more processes are waiting indefinitely for resources held by each other, creating a permanent block in the system. Our project, Deadlock Visualizer using Python and Pygame, helps you understand this concept visually. It shows how deadlocks happen, how they can be avoided, and how systems recover from them. The main objectives of our project are to visually demonstrate the concept of deadlock in an operating system, to understand the difference between deadlock simulation, avoidance, and recovery, and to make learning more interactive and engaging through graphical representation. For implementation, we used Python version 3.10 as our programming language, the Pygame library to design the graphical interface, and Visual Studio Code as our integrated development environment for writing and debugging the code. Our visualizer has three main modules. The first one, Simulate Deadlock, shows a circular wait where processes are stuck waiting for each other. The second mode, Avoid Deadlock, uses the banker's algorithm to show a safe sequence of resource allocation. The third mode, Detect and Recover, identifies a deadlock, terminates one process, and releases resources to recover the system. In our simulation, processes are represented as blue circles, resources are represented as green squares, and arrows represent requests and allocations. The user can switch between three modes, simulation, avoidance, and recovery, to understand how the operating system manages resources under each condition. In the avoidance mode, the banker's algorithm checks whether granting a resource keeps the system in a safe state. If safe, the resource is allocated. If not, the process waits until it becomes safe. For detection and recovery, the system builds a wait for graph. If a cycle is found, a deadlock exists. The system then terminates one process to release resources and recover successfully. The output clearly visualizes each case. In simulation mode, red arrows show a circular wait and display the message, deadlock occurred. In avoidance mode, green arrows show a safe sequence with the message, safe state achieved. And in detection and recovery mode, the deadlock is detected, a process is terminated, and the system displays, system recovered successfully. Our project effectively demonstrates how deadlocks occur, how they can be avoided, and how the system can recover. By using Python and Pygame, we turned a complex operating system concept into an easy, interactive visual learning experience. In short, the Deadlock Visualizer enhances understanding through simulation, making learning simple, clear, and fun. Thank you for watching. This is our Deadlock Visualizer project, developed